Okay, so we're in section 5.4. We're going to skip over the true-false ones today. We're going to start in with the ones where we actually do some calculations. So it says use the prime factors method to find the greatest common factor for each group of numbers. So for 11 we have 60 and 140. So if we go back to the greatest prime factors method, it says write the prime factorization for each number. So the prime factorization we do by finding all the prime numbers multiplied together that give you the number. So I'm dividing by 2 here until I get an odd number. And then I'm going to try 3, and that leaves me 5. So my prime factorization for 60 is 2 squared times 3 times 5. And we could do the same thing for 140. So we divide by 2 until we get an odd number. Then we try 3. 3 doesn't work. Then 5 does work. 35 divided by 5 is 7. So these are all the prime numbers. So we have 140 is 2 squared times 5 times 7. Okay, so that's step 1. Choose all primes common to all factorizations, with each prime raised to the least exponent that has a factorization. So these are the common ones, 2 and 5, and they're raised to the second power. So what we do is take 2 to the second power times 5. And that's 4 times 5, which is equal to 20. So 20 is your greatest common factor. Okay, let's look at 14. 136 and 544. Okay, let's stop there. My wife, this is Tuesday, second hurricane day, so she came down to tell me it's snowing, so I had to stop so she could tell me that. Okay, same thing. Take each one, do prime factorization. So we divide by 2, and that gives us 68. Again, you can use your calculator. I'm just doing it in my head, so I don't have to use my calculator. Okay, 69 divided by 2 is 34. 34 divided by 2 is 17. 17 is a prime number. So 136 is 2 times 2 times 2, which is 2 cubed times 17, which is a prime number. Okay, the next one is 544. So we'll divide that by 2. And I'm going to use my calculator, just on the safe side. 272. Okay, you can divide by 2 because it's even still. Divided by 2, I get 136, which is still even. So I divide by 2 again. I get 68. Still even, so I can divide it by 2 again. I get 34. Still even, so I can divide it by 2 again, and I get 17. So 544 is equal to, I get 2 times 2 times 2, I got 5 2s, so it's 2 to the 5th power times 17. So the common factors are 2 and 17, but I only have 3 of them here, and I have 5 of them there, so use a smaller one. So I'll have 2 cubed times 17, because I have 17 in both of those. That's 8 times 17. 2 cubed is 8. 8 times 17 is 136. So 544 divided by 136. 544 divided by 136 is 4, and of course 136 divided by 136 is 1. Okay, so that's the prime factor method. Let's go on to the next one, which is use the method of dividing by prime factors to find the greatest common factor for each group of numbers. So our two numbers are 72 and 90. So let's go back and look at what it says. Dividing by prime numbers factor. Okay, so write the numbers in a row. Okay, 72, 90. Divide each number by a common prime factor. Try 2. Well, yeah, because it's even. So you divide both of those by 2, and you get 36 and 45. Okay, well, we can't divide by 2 because one's odd and one's even. So then we say, okay, can you divide it by 3? Well, yes, you can, because 36 divided by 3 is 12. 45 divided by 3 is 15. Okay. Now, is there a prime number that you can divide these by? Well, again, you can divide by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. And now we're down to numbers that we can't divide out anymore. So then, to divide the quotients by a common prime factor, continue until no primes will divide into all the quotients. That's where we're at right now. The product of primes in steps 2 and 3 is the greatest common factor. So if we take 2 times 3 times 3, that would be 18. And let's see if that's the right answer or not. Yes, it is. Okay. Let's try problem 20. 384 and 222. Okay, so we're going to write these in a row. 384, 222. Again, we divide by 2. So 384 divided by 2 is 192. 222 divided by 2 is 111. Okay, so we can't divide by 2 because one of these is odd. And just checking to make sure I had the microphone on. My usual paranoia about that. Okay, so we try 3. 192 divided by 3 is 64. And 111 divided by 3 is 37. So we can't do that. So we divide by 3. We get 64. 37. I think 37 is a prime number. I don't know of any number that divides it. So all we have is 2 times 3. So 2 times 3 is equal to 6, and 6 is the greatest common factor, which is true. Okay, now let's do one with 3. So we're going to do problem 22. So you have 450 and 1155 and 630. Okay, write those in a row. Divide by something. Well, we can't divide by 2 because we already have an odd number. So the next option would be 3. So 450 divided by 3 is 150. 1155 divided by 3 is 385. And 630 divided by 3 is 210. So those all work. So we're going to divide each one by 3. 150, 385, 210. Okay. Now, can we divide those by 3? Well, you can. This 150 divided by 3, yeah, because you get 50. 385 is the one that's in question. 385 divided by 3 is no. That's 128.333. So let's try the next prime number, which is 5. 150 divided by 5. 385 divided by 5. Of course, these are all going to be divisible by 5 because they end in 0 or 5. So we know it's going to work out. So each one, we get 30, 77, 42. Now, 7 these are not divided by 5 because we don't have 0 or 5 in the last number. 7 is the next one. And we know that you can't divide 30 by 7. This you can divide by 7. This you can divide by 7. But this one you couldn't. So 7 is not going to work. 11 is not going to work. And we're pretty much out of luck. So the only ones that we have are 3 and 5. So the greatest common factor is 15. Okay. The next one says use the Euclidean algorithm to find the greatest common factor of each group of numbers. So what the heck is the Euclidean algorithm? Well, it's a good place to look is the book. Yes, that's an interesting one. So, okay. So the best way to do it, let's just it says begin by dividing the larger by the smaller. Divide the larger by the smaller. So that's going to go 1 time in there. And if we multiply by 1 times 32 is 32. And you subtract 6. 6 minus 2 is 4. We end up with 24. Okay, now what we do is we take this number, 24, and we divide by the next number, 32, which is this number. Okay, so again, we just get 1. So you take 24. 1 times 24 is 24. 12 minus 4 is 8. So that's what you get. And apparently you just keep doing this until you get to 0. Okay, so what do we do next? Next thing we do is we take this number, 24, and divide that by this number, 8. And when you do that, you get 3, and that's 24, and you get a 0 remainder. And so it looks like this number here is the one that is the next, and the next to previous one. So they're saying 8 is that. And can you divide 32 by 8? Yeah, 4 times. Can you divide 56 by 8? 7 times? Yes, so it works out right. Okay, so let's do this again. Same problem, just think about it. So you take the larger number divided by the small number. You get a remainder. You take that remainder, move it to here, and you take this number and move it to there. Okay, so then you do this and you move, you get an 8 reminder here, you bring that down there, and then you bring this number down there to here, and then once you get a 0 remainder, you go back up 1 step, take that number as your least common factor, greatest common factor. Okay, let's try it again. That's kind of an interesting approach. I've never used that before. So let's do it on 26. So we have 72, 126. Okay, so we take 126 divided by 72. We'll go in 1 time. So 1 times 72 is 72. Subtract, 6 minus 2 is 4. 12 minus 7 is 5. So you get 54. Okay, now this goes down here, and this comes down there, so you get 54 divided by 72. 72 divided by 54. Again, goes in 1 time. 1 times 54 is 54. 12 minus 4 is 8. You borrowed 1, so we have 18 left. Okay, now this goes down here, 18. This comes down there, you get 54. So how many times can 18 go into 54? 3, 4, 3 times, I guess. So you have 3 times 18 is, that's 24, plus 2 is 54. Get a 0 remainder, so you go back up to here, just like we did before, and so 18 is the common factor. And that is a common factor. That is a common factor. 72 divided by 18 is 4, and 126 divided by 18 is 7. So we're going to do one more just because it's kind of an unusual way of doing things. So we have 280. Of course, you can only do this with two numbers. Okay, so now 360, the larger number, divided by 280, smaller number. It goes in one time, write down 280. Get 0, 16 minus 8 is 8, so 80. You bring that to here, 80 is divided into 280, it's this number, and we get how many times? 3. So we get 240. Subtract that, you get 40. Okay, now we take 40 down here, and we bring the 80 down to here. Goes in 2 times, we get a 0 remainder. So we go back up to here, and it says 40, which is true. 28 divided by 40 is 70, or 7, and 360 divided by 40 is 9. Interesting. Okay. So let's stop there, and